electronics. One of our major products is this industrial strength chiller. So right here we had this system cooling this water. It's running a standard refrigerant cycle. So here's a little compressor and the heat exchangers. We have it all controlled with an Arduino Mega, and that is able to control the speed of the compressor and the fan to maintain a level temperature of the water. But it's very compact and portable, and it's very powerful, so it'll deliver 800 watts of cooling. So you can go well below freezing with this, and from just a small 12-volt battery.
Hi, I'm Daryl, and what I'm trying to teach or show people today is the NIH 3D Print Exchange, which is a place to share and create 3D printable files that pertain to the biological and biomedical sciences. So for example, here's a model of how a virus comes together. It comes in little pieces, all symmetric. We're simulating the intermolecular forces with magnets. As we apply energy, what happens is that these 3D printed parts start to assemble themselves together because of the intermolecular forces that we're showing. So eventually, given enough energy and time, random motion will create the virus. So this is an educational toy that we're making using 3D printing to help teach biology. Another educational tool that we have with us is our DNA building kit. So here what we do, we take a sequence. Here's my C, and let's see, I'll connect up an A, start making a sequence, C-A-T. Here's my DNA sequence, C-A-T. Now, in life, there are 3 billion of these letters in a human, but here I've only got 3 letters. What I have to do is now make the anti-sense. So I know that the red always goes with the green. So I start to build that, and I know that the yellow always goes with the blue. Here I am making my binding partners, and automatically, because of the geometry and the chemistry that's represented here, I start to get the double helix. And eventually, what you see is a big, long helix made up of all these nucleotide models. Here's a 3D printed frog, a frog dissection kit. So from here I see, if I take off the liver from my frog, I can see the heart, the stomach, the bladder, the intestines. And this way, I can teach frog anatomy without having to sacrifice a whole bunch of frogs. It's a 3D printed frog. And one more. This is a 3D printed microscope. With this microscope, I use 3D printed parts and lenses from old disposable cameras. And in this microscope, this actually gives me about an 80 times magnification. With it, I can clearly see the pixels in my phone and compare, for example, my old phone with somebody's brand new Apple iPhone Retina display and see that their pixels are much smaller than the pixels in my phone. So this microscope actually works, and it was made on a 3D printer.
Hi, I'm Ben Harris with Harris Educational. I'm here today at the DC Mini Maker Faire, the first DC Mini Maker Faire in Washington, D.C. I'm here to show off my Harris Educational products I maker-made by myself. This is my first kit. It's called Reinventing Edison, Build Your Own Light Bulb. It's a science kit for kids about 4th grade through high school. And inside I've got a piece of ordinary pencil lead, carbon pencil lead, and I have evacuated the air from the chamber. I have pumped the air out, and now I'm going to connect a voltage, and I'm going to make an incandescent bulb. So it's going to start to glow, get brighter and brighter, and make an incandescent bulb. As a community outreach, I have created a group called the Alamance Makers Guild, where I'm from in Burlington, North Carolina. We actually meet, have speakers, and we're working toward opening a makerspace. And we also have a Burlington Mini Maker Faire that we produce in Burlington, North Carolina.